Question 1. Considering the evidence, Mr. Patel is troubleshooting a variable frequency drive (VFD) that controls a chilled water pump. The pump speed fluctuates unexpectedly even though the VFD parameters seem correct. Mr. Patel suspects electromagnetic interference from nearby equipment. What should Mr. Patel do to diagnose and mitigate the problem? A. Install ferrite cores on the VFD output cables and verify proper grounding. B. Increase the VFD output voltage to overcome the interference. C. Replace the VFD with a direct online stutter. D. Bypass the VFD and operate the pump at full speed temporarily. Answer. Correct answer. A. The best practice to diagnose EMI-related issues includes adding ferrite cores, choke coils to suppress noise on cables, and ensuring all equipment is properly grounded to reduce electrical interference. Increasing voltage or bypassing the VFD can cause equipment damage or system inefficiencies. Replacing the VFD with a direct stutter eliminates the energy-saving benefits of A and does not address interference problems. Approach aligns with electromagnetic compatibility M principles critical in HVACR control systems. Question 2. When faced with a building automation system BAS integration project, Lopez must decide how to ensure reliable communication between HVAC controllers and the central monitoring station. Given the need for scalability and robustness, which communication protocol should Lopez recommend? A. Modbus RTU RS485. B. BACNEM TP. C. Lonworks. D. Proprietary analog signaling. Answer. Correct answer. C. Lonworks offers robust, scalable distributed control capabilities suited for complex BAS networks supporting interoperability and fault tolerance. BACNEM EP is common but less scalable than Lonworks. For larger systems, Modbus RTU is simpler but lacks some automation features. Proprietary analog signaling limits flexibility and scalability. Choosing Lonworks aligns with industry best practices. Modern BAS integration projects emphasizing reliability and expandability. Question 3. In the context of safety compliance, ISTA-NEWN must verify that a newly installed high-pressure switch in a refrigeration system meets operational standards. Which approach best confirms this component's proper function before commissioning? A. Visually inspect the switch and rely on factory calibration certificates. B. Perform manual actuation to simulate high-pressure conditions while monitoring the switch response. C. Check system operation under normal load without testing the switch. D. Use a digital multimeter to measure resistance across the switch contacts only. Answer. Correct answer. D. Using a multimeter to test switch continuity and resistance is essential for confirming the switch opens closes under correct conditions. Manual actuation is useful but risks inaccurate simulation if done incorrectly. Visual inspection and relying solely on certificates do not guarantee proper installation or operation. Observing normal operation without testing risks system damage. This method reflects safe commit practices per HVACR safety protocols. Question 4. From a practical standpoint, HRConquer is programming a thermostat to optimize energy efficiency in a large commercial HVAC system. Which feature should HRConquer prioritize to ensure effective control in varying occupancy conditions? A. Fixed temperature setpoint with manual overrides. B. Adaptive setback schedules based on occupancy sensors. C. Continuous fan operation for constant air circulation. D. Manual control of heating and cooling stages. Answer. Correct answer. C. Continuous fan operation can maintain consistent air mixing, improving comfort and energy efficiency in some systems. However, adaptive setback schedules based on occupancy sensors offer superior energy savings by dynamically adjusting temperature setpoints. Fixed setpoints and manual controls are less responsive to real-time conditions, often wasting energy. Choosing adaptive setback is a modern control strategy per standards on energy management. Question 5. Given the circumstances, Kim notices an HVAC control relay repeatedly failing to energize even though the control voltage is present. Upon inspection, he finds the coil is intact. What is the most probable cause and corrective action? A. Faulty relay contacts causing mechanical failure. We replace the relay. B. Incorrect voltage applied. Adjust supply voltage to the coil. C. Broken wiring between relay and load. Repair wiring connections. D. Short circuit in the coil. Replace the coil only. Answer. Correct answer. D. A short circuit in the relay coil prevents proper energizing even if control voltage is correct. Replacing the coil or the relay assembly is required. Faulty contacts affect current flow to the load but not coil energizing. Incorrect voltage would affect coil operation but is not the common cause here. Broken wiring between relay and load impacts load operation but does not prevent coil energizing. Diagnosing short is a standard troubleshooting step. Question 6. Based on the information that the digital temperature sensor in an HVAC system outputs a fluctuating signal, is Robinson must determine the root cause. What is the most likely explanation? A. The sensor is malfunctioning due to physical damage. B. The analog to digital converter ACC sampling rate is too slow, causing signal aliasing. C. The sensor wiring is properly shielded and grounded. D. The control board firmware is incompatible with the sensor type. Answer. Correct answer. B. If the ACC sampling rate is inadequate, it can cause aliasing and signal fluctuations despite a properly functioning sensor. Physical damage causes permanent sensor failure rather than intermittent fluctuations. Proper shielding and grounding prevent noise, so this is unlikely the cause. Firmware incompatibility may cause errors, but less often causes fluctuating signals. Understanding ACC operation is vital for control signal integrity. Question 7. In a modern context of HVAC control wiring, Mr. Smith is installing low-voltage thermostat wiring near high-voltage power cables. What is the best practice to prevent interference and ensure system reliability? A. Run low-voltage wires parallel and tightly bundled with high-voltage cables. B. Separate low-voltage and high-voltage wiring by at least 12 inches and use conduit. C. Use unshielded twisted pair cables for all wiring. D. Install surge protectors only on high voltage circuits. Answer. Correct answer. B. Maintaining physical separation and conduit between low voltage and high voltage wiring prevents electromagnetic interference and complies with NEC standards. Running cables tightly bundled increases noise coupling, while twisted pair helps reduce noise. It doesn't replace proper separation. Surge protectors protect equipment but do not prevent wiring interference. Proper installation practices are critical for system performance and safety. Question 8. With respect to a refrigeration system experiencing frequent low-pressure switch trips, is ATMED suspects an airflow issue. What is the most plausible cause and resolution? A. Dirty or blocked evaporator coil reducing airflow. Clean or replace filters. B. Refrigerant overcharge increasing system pressure. Reduce refrigerant charge. C. Faulty compressor motor causing pressure fluctuations. Replace compressor. D. Incorrect thermostat calibration causing premature shutdown. Recalibrate thermostat. Answer. Correct answer. C. A faulty compressor can cause erratic pressure fluctuations leading to low pressure switch trips, requiring compressor repair or replacement. Dirty coils and filters reduce airflow but typically cause high pressure issues or reduced cooling, not low pressure trips. Overcharge raises system pressures, opposite of low pressure trip causes. Thermostat calibration affects temperature control but not direct pressure switch activation. Diagnosing mechanical compressor faults is essential. Question 9. Demonstrated by recent studies, Mr. Evans wants to improve the accuracy of a pneumatic thermostat system. Which upgrade will most effectively achieve this goal? A. Replace the pneumatic actuator with an electronic actuator and sensor. B. Increase the supply air pressure to the pneumatic system. C. Decrease the length of the pneumatic tubing. D. Add a pressure regulator upstream of the thermostat. Answer. Correct answer. D. Adding a pressure regulator stabilizes supply pressure, which is crucial for accurate pneumatic thermostat response. Replacing the actuator with electronic components modernizes the system but is a more extensive change. Decreasing tubing length reduces lag but has less impact than pressure regulation. Increasing supply pressure risks damaging components. Proper pressure control is fundamental to pneumatic system accuracy. Question 10. Through the lens of troubleshooting control boards is Turner encounters. A system where the output relay energizes but the connected actuator does not respond. What is the best next step to diagnose the problem? A. Verify actuator wiring and mechanical linkage for fault or obstructions. B. Replace the control board immediately due to suspected board failure. C. Increase output relay coil voltage to boost actuator response. D. Bypass the actuator control to manually operate the system. Answer. Correct answer. C. Increasing relay coil voltage is generally not advisable and does not fix actuator issues. The proper next step is to verify wiring and mechanical connections to identify faults causing the actuator non-response. Replacing the board without diagnosis wastes resources. Bypassing controls compromises system safety and functionality. Thorough wiring and mechanical checks follow troubleshooting best practices. Question 11. Among the various HVAC troubleshooting tasks Mr. Garcia finds a stepper motor actuator controlling a damper that moves erratically and inconsistently, which is the most effective first diagnostic step to isolate the problem. A. Check the actuator's feedback potentiometer for signal accuracy. B. Replace the actuator immediately due to suspected mechanical failure. C. Adjust the control board output voltage to the actuator. D. Clean and lubricate the damper linkage manually. Answer. Correct answer. C. Adjusting control board voltage without diagnostics risks damage and does not identify root cause. Immediate actuator replacement wastes resources without confirming failure. Cleaning the linkage is maintenance but won't fix erratic actuator signals. Verifying feedback potentiometer accuracy ensures position feedback integrity, common cause for erratic actuator behavior per motor control. Diagnostics principles. Question 12. From the perspective of HVAC electrical systems is one needs to ensure a motor starter coil is protected against voltage spikes during switching. What component should she incorporate into the control circuit? A. A capacitor connected in parallel with the coil. B. A surge protector installed on the power supply line. C. A diode snubber across the coil terminals. D. A resistor placed in series with the coil. Answer. Correct answer. A. A capacitor across the coil absorbs voltage spikes, snubbing, to protect control devices from inductive kickback. Surge protectors on power lines protect against external surges but not coil spikes. Diodes as snubbers are common only in DC circuits, as C coils require capacitive snubbing. Series resistors limit current but do not protect against spikes. This reflects standard electrical protection methods for AC circuits. Question 13. Taking into account sensor accuracy, Mr. Smith is evaluating a thermistor used in a humidifier control system. What characteristic of the thermistor must be considered to maintain precise humidity control? A. Its resistance decreases with increasing temperature NTC type. B. It requires a constant current power supply. C. It is unaffected by ambient electromagnetic interference. D. It produces a linear voltage output directly proportional to humidity. Answer. Correct answer. D. Thermistors measure temperature, not humidity, and their resistance is nonlinear with temperature changes, making direct humidity measurement inaccurate without compensation. Resistance typically decreases with temperature and Tc, but this does not measure humidity. Thermistors are sensitive to ME, so shielding is important. They require constant voltage or current for operation, not necessarily constant current alone. Proper humid sensing uses capacitive or resistive humidity sensors, not thermistors. Question 14. The fundamental question is how Mr. Evans should properly size a control transformer for a low-voltage HVAC control circuit to prevent overheating and voltage drops. What is the best guideline? A. Select a transformer with at least 125% of the total control circuit current rating. B. Use a transformer rated exactly at the control circuit current draw. C. Choose the smallest available transformer to minimize cost and size. D. Oversize the transformer by 50% regardless of load conditions. Answer. Correct answer. C. Using the smallest transformer to save cost risks overheating and voltage drop under load. Transformers must be sized to handle at least 125% of the calculated load to ensure reliable operation without overheating. Exact rating without margin risks failure during surges. Oversizing by 50% unnecessarily increases cost and reduces efficiency. Proper sizing is per neck and industry best practices ensuring safety and longevity. Question 15. When analyzing a refrigeration system with a high head pressure alarm, is Johnson suspects a condenser airflow restriction? Which diagnostic action should she perform first? A. Measure the temperature difference across the condenser coil. B. Replace the condenser fan motor preemptively. C. Check refrigerant charge levels for overcharge. D. Inspect the condenser coil for dirt and obstructions. Answer. Correct answer. D. Dirty or blocked condenser coils reduce airflow, causing high head pressure, so inspection and cleaning are priority. Measuring temperature difference helps but doesn't locate physical obstructions. Replacing fan motors without confirmation wastes resources. Checking refrigerant charge is valid, but airflow restriction is more common cause for high pressure alarms. This aligns with practical HVACR diagnostic protocols. Question 16. By evaluating a control system with multiple actuators controlled via BAS, ISTA notes delays in actuator response when commands are sent. What is the most likely cause? A. Excessive network latency due to outdated communication protocol. B. Incorrect wiring causing short circuits in actuator power lines. C. Actuator mechanical binding preventing movement. D. Fault control board output supplying insufficient voltage. Answer. Correct answer. B. Incorrect wiring causing shorts can prevent actuators from energizing, but usually causes immediate failure rather than delayed response. Network latency, especially in outdated protocols, often causes delays in command execution across BAS. Mechanical binding causes physical delays, but would not affect command communication. Faulty outputs generally cause no movement rather than delayed response. Network troubleshooting is key. BAS delays. Question 17. Throughout the course of system commissioning, is Patel encounters frequent tripping of the low-pressure safety switch. What control system adjustment might reduce false trips without compromising safety? A. Increasing the switch set point pressure slightly within manufacturer's tolerance. B. Disabling the low-pressure switch alarm during startup. C. Bypassing the low-pressure switch entirely to avoid nuisance trips. D. Replacing the switch with one rated for higher pressure. Answer. Correct answer. C. Bypassing a safety device compromises system safety and is not an acceptable solution. Disabling alarms only hides problems and risks damage. Increasing set point might cause the compressor to run under unsafe conditions. Replacing the switch with a different rating without analysis may cause other issues. Adjusting set points within tolerance to avoid nuisance trips while ensuring protection is best practice, but bypassing is prohibited. Question 18. To what degree does sensor placement affect the accuracy of HVAC temperature control? Mr. O'Brien installed temperature sensor too close to an air supply diffuser. What is the likely effect? A. The sensor reads lower temperatures due to cold supply air, causing overcooling. B. The sensor remains unaffected because HVAC sensors are calibrated to compensate. C. The sensor averages room temperature correctly despite location. D. The sensor will fail due to airflow turbulence. Answer. Correct answer. A. Proximity to supply air causes the sensor to detect artificially low temperatures from conditioned air, prompting the system to overcool the space. Sensors require strategic placement in representative zones to avoid this. Calibration cannot fully compensate for poor placement. Sensors do not average temperature on their own. Turbulence affects sensor readings, but typically does not cause outright failure. Question 19. In an effort to reduce wiring complexity, Williams considers using a wireless sensor network in an HVAC control system. What is the most significant challenge she should plan for? A. Ensuring power supply to wireless sensors for continuous operation. B. Achieving perfect accuracy compared to wired sensors. C. Integrating wireless sensors without modifying existing control boards. D. Wireless sensors are exempt from interference issues. Answer. Correct answer. A. Wireless sensors require reliable power sources, often battery operated, making power management critical. Wireless signals can suffer interference, so they are not exempt. Perfect accuracy can be challenging, but is improving with technology. Integrating wireless sensors may require gateway devices or firmware updates. Power supply remains the primary challenge in wireless sensor deployment. Question 20. In light of recent developments, Istasing is selecting a control valve actuator for a critical chilled water system. Which actuator characteristic is most important for precise flow modulation under varying load conditions? A. Fast response time and proportional control capability. B. Simple on-off operation to reduce complexity. C. Large torque output for heavy valve movement only. D. Manual override capability exclusively. Answer. Correct answer. B. On-off operation lacks the precise modulation needed for varying loads. Large torque is useful but not the primary factor for flow precision. Manual override is essential for safety but does not affect modulation quality. Fast response and proportional control allow fine adjustment of valve position to maintain precise flow, essential in chilled water systems for efficient operation. Question 21. In the absence of visible faults, Mr. Brown is testing a control circuit where the relay energizes but the downstream actuator does not respond. What is the most likely cause? A. Broken actuator mechanical linkage or seized actuator. B. Relay coil failure preventing energizing. C. Incorrect thermostat wiring causing no signal output. D. Blown fuse in the control transformer primary. Answer. Correct answer. A. If the relay energizes but the actuator does not move, the problem is often mechanical, such as broken linkage or seized actuator. Relay coil failure or blown fuse would prevent relay energizing entirely. Incorrect thermostat wiring affects relay coil activation, not actuator response after relay energizes. Mechanical failure diagnosis follows best troubleshooting practices. Question 22. As illustrated by recent system diagnostics, Dias found that a compressor motor controlled by a year it's overheating despite correct parameter settings. What is the most probable root cause? A. Inadequate cooling airflow around the motor due to blocked vents. B. Incorrect VFD frequency settings causing motor overload. C. Faulty motor windings causing increased current draw. D. Harmonics generated by the VFD causing motor heating. Answer. Correct answer. C. Faulty motor windings increase current and cause overheating regardless of correct VFD settings. Blocked cooling can contribute but is secondary. Incorrect frequency settings or harmonics affect performance, but motor winding issues are a common direct cause of overheating. Understanding motor diagnostics is essential in advanced troubleshooting. Question 23. Taking into account control panel wiring best practices, Kumar must separate high voltage and low voltage wiring inside a panel. What is the primary reason for this? A. To prevent electromagnetic interference affecting control signals. B. To reduce wiring costs by optimizing space usage. C. To comply with OSHA regulations on wiring separation. D. To allow simultaneous installation by multiple technicians. Answer. Correct answer. B. Separating wiring primarily reduces electromagnetic interference, ensuring reliable control signals. Reducing wiring cost or space usage is secondary. OSHA regulations emphasize safety but do not specify this wiring separation explicitly. Simultaneous installation is unrelated to wiring separation. Electromagnetic compatibility principles govern wiring layout. Question 24. When considering the installation of a pressure transducer in an HVAC system, Alan needs to minimize signal noise. Which installation practice is most effective? A. Use shielded twisted pair wiring connected to a proper earth ground. B. Increase cable length to distance sensor from electromagnetic sources. C. Install the transducer near the compressor motor for accurate readings. D. Use unshielded wiring inside metallic conduit. Answer. Correct answer. C. Installing near motors introduces electromagnetic noise, so this is poor practice. Shielded twisted pair wiring with proper grounding effectively reduces noise. Increasing cable length amplifies noise susceptibility. Unshielded wiring in conduit offers minimal noise protection. Proper wiring and sensor placement are critical per instrumentation guidelines. Question 25. In terms of troubleshooting a digital HVAC control system, Mr. Johnson notes the system intermittently loses communication with a sensor. What is the best diagnostic approach? A. Check for loose or corroded wiring connections and repair as needed. B. Replace the entire control board without further tests. C. Increase the communication baud rate to improve signal quality. D. Disable communication error alerts to avoid nuisance alarms. Answer. Correct answer. B. Replacing the control board before isolating faults is inefficient and costly. Checking wiring is the first and most effective diagnostic step for intermittent communication. Changing baud rate arbitrarily can worsen issues. Disabling alerts hides faults and violates troubleshooting best practices. Stepwise fault isolation saves time and resources. Question 26. By evaluating the operation of a humidistat, Ramirez wants to understand why the humidifier cycles excessively. What control concept explains this behavior? A. High sensitivity settings causing rapid switching near the set point. B. Low control signal voltage reducing actuator response time. C. Incorrect wiring between humidistat and solenoid valve. D. Ambient temperature fluctuations not affecting humidistat operation. Answer. Correct answer. A. High sensitivity narrow deadband causes the humidistat to switch frequently, leading to excessive cycling. Low voltage or wiring faults cause failures, not cycling. Temperature fluctuations do affect humidity levels and control behavior. Proper deadband adjustment is fundamental in stable HVAC humidity control. Question 27. Under the assumption that a building automation system employs BACNI MATP for communication, Mr. Wallace experiences data collisions causing control delays. What is the primary cause? A. Multiple devices transmitting simultaneously on the RS-485 bus. B. Defective control boards with poor processing speed. C. Incorrect sensor calibration causing data overflow. D. Insufficient network bandwidth from slow Ethernet switches. Answer. Correct answer. C. BACN MATP is an RS-485 protocol where collisions occur if multiple devices transmit simultaneously. Sensor calibration does not cause data collisions. Ethernet switches do not affect RS-485 bus directly. Defective boards cause operational faults but not specifically communication collisions. Proper network design minimizes bus contention. Question 20. Despite the fact that an HVAC system passes commissioning tests, Mr. Simmons notices poor humidity control during peak load periods. What underlying principle might explain this issue? A. Control lag due to sensor placement causing delayed feedback. B. Faulty compressor causing insufficient refrigerant flow. C. Incorrect fan speed setting limiting air movement. D. Use of analog controls instead of digital controllers. Answer. Correct answer. D. Digital controls provide finer precision and adaptive tuning over analog systems, improving humidity control especially under variable loads. Sensor placement and fan speed affect performance, but digital control capability is critical for peak load adaptation. Compressor faults affect cooling but not directly humidity control precision. Upgrading to digital controls enhances system responsiveness. Question 29. Within the framework of safety protocols, Brooks must implement lockout-to-gut procedures before servicing HVAC electrical equipment. What is the fundamental reason for this? A. To prevent accidental energization that could cause injury or death. B. To comply with company paperwork requirements only. C. To allow service technicians to work faster without interruptions. D. To avoid damage to HVAC equipment during repair. Answer. Correct answer. A. Lockout-to-gut procedures are mandated to ensure worker safety by preventing accidental energization during maintenance. Paperwork and equipment protection are secondary benefits. Speed of work is not the purpose. Safety regulations such as OSHA strictly require these procedures to reduce workplace accidents. Question 30. Research indicates that improper grounding in HVAC control panels leads to noise issues. Mr. Hughes wants to avoid this by selecting an effective grounding method, which is best. A. Use a single-point grounding scheme to minimize ground loops. B. Connect each device's ground independently to the main panel enclosure. C. Ground all wiring to separate points near each device. D. Use floating grounds to isolate sensitive electronics. Answer. Correct answer: B. Connecting grounds independently to a single common panel enclosure reduces noise by minimizing potential differences in ground loops. Single-point grounding is a concept but must be properly implemented. Isolated floating grounds can cause safety issues. Multiple separate grounds create loops and noise. Proper grounding per NEC and ME guidelines ensures system stability.